Let's get started. Any questions? Okay. Okay. So today will be the final project. Okay. So I think today will be the last class of this semester, and I will still be here on Thursday at the same time, but it will be like office hour. So if you have any questions, you can come and ask. Okay, let me start share my screen. Okay, so final project. First of all, make sure you check the video and the lab menu on the Brightspace so you have a general understand so what's the final project. And hopefully you already attend the seminar Ben hold earlier. Okay, and also there's a pre-lab for the final project, so it's submit for the feedback. Okay, so it's not going to grade it, but still I recommend you submit on the Brightspace. We will try to give you the feedback before end of tomorrow, I think. And so the reason I want to check the pre-lab is that so on the pre-lab you're going to draw your schematic and calculate the value you need for each component. Okay, so we want to check your like topology is correct or not before you like build the circuit. Okay. Okay, and the important thing here, the deadline. Okay, so the deadline for the final project report will be August 2nd. So that's next Tuesday. Okay, so which is 1 week from now. So you'll have 1 week should be enough for the final project, and but still try to start early. Okay. And start with subcircuit. I will talk about this soon. Okay, so let's talk about the final project. Okay, so the final project is audio equalizer. So if you read manual, you should have a general understanding for this circuit. So it's made for speaker. Okay, so for most of the speaker or some fancy speaker, they should have a equalizer circuit. So that's equalizer is something looks like this. Okay, let me show you here. So first of all, for a circuit for a speaker, the system looks like this. Okay, so first of all, it has a equalizer, and then it has a volume control, and then it has a power amplifier to make a sound louder, and then they have a tweeter and a woofer for high frequency music and low frequency music. For our final project, since you are using 82, we will remove the power amplifier and the filter after power amplifier. Okay, so don't worry about this part. The only thing you need to build is equalizer and volume control. Okay, so here is the equalizer subsystem block diagram. Okay, first of all, we are going to divide the music signal into 3 paths. Okay, like low pass, mid pass, and also the high pass. Okay, which means the low frequency signal go to the low pass filter, and the mid frequency go to mid band pass filter, then the high frequency one. After each filter, there is a controller for each filter. Okay, so there's a base control, mid control, and a treble control. Okay, so then after that, so for this those 3 controllers, so you can control the like the music signal amplitude of each different frequency. Okay, for example, if you want a stronger bass sounds, then you can turn off the bass control and then make the other two frequency have lower amplitude. Okay, so that's the reason we want a controller for different filter. And then after each individual control, there is a total volume control. Okay, you're going to use a semi amplifier in this part. So I already labeled this here, where you can find the theory of each part. So for the filter part, which we learned in Lab 10, okay, for the control, we are going to use the amplifier, since we know the amplifier control the amplitude. And then again, the semi amplifier is from Lab 8. Okay, so you didn't build semi amplifier in the Lab 8, but if you check the lab manual, there is a part talk about the semi amplifier. Okay, so if you remember this circuit right here, I mean this block diagram right here, then we can go to the document called typology that's also uploaded on the Brightspace. Okay, equal ladder typology. Let me use this one. So what's this circuit is actually the equalizer part. Okay, if you see there are three filter right here. So if you go to the circuit part, so there are three filter right here. Okay, so those part are the filter part, and then after each filter there are controller part. Okay, so those are the controller part, and then there's a semi amplifier. Okay, so that's how you transfer this block diagram into this circuit diagram. Okay, again, this is just a reference circuit. You don't have to build exactly same as this. If you have your own idea, you can build your own circuit. Okay, so but the general idea should be similar. Okay, so so after you have this, okay, before you build this circuit, okay, before you build this circuit on the breadboard, you need to calculate the value for each component. Okay, so how you can calculate the value is according to the second. Okay, let's just use this. Right here. So according to the requirements right here, so the specifications. So first of all, those three requirements. Okay, those three requirements will make the value for the filter part. Okay, so you have the low pass filter, the cutoff frequency is 320. You have a band pass filter, so it has a cutoff frequency at 320 hertz and 3.2 kHz. And then the high pass filter, the cutoff frequency is 3.2 kHz. Okay, so that's the cutoff frequency for the three filter. Then you can use those value to calculate the use those specs to calculate the value for the component in the filter, like R1, C1. So that's a low pass filter. R3, C2, C3, R5, that's a band pass filter. C4 and R7, that's a high pass filter. Okay, so that's how you can calculate the value for the filter part. The equation it should be given in the lab 10, lab 8. Okay, just use the cutoff frequency equation. For the bandpass filter, it's a little bit confused. I will talk about the bandpass more later. Okay, so after you get the value for the filter part, you can start to calculate the value for the amplifier part. So what's the requirement here is you're going to use when the equalizer knobs at maximum, the output will be 100 million VRMS. So that's with at the 1 volt VPP. Okay, when the 1 volt VPP is at input, the output should be 100 million VRMS when the knobs at maximum. First of all, what's the knobs here? Is if you see the circuit diagram, there are some variable resistor. And what you're going to use is you're going to use potential meter. Okay, so when they set knobs at maximum, which means this resistor will be a 10K ohm resistor. Okay, if you remember, the maximum resistance of the potential meter is 10K. And when this at minima, that means your potential meter will be at 0 ohm. Okay, so first requirement here is should be simple to satisfy. When you think all the knobs to minima, the output should be smaller than 15 million VRMS. So theoretically, your output should be just 0. So this one is simple to require to satisfy. If you remember the equation, when this is 0, the gain of the amplifier will be 0. So there will be no signal past the amplifier. And then the second requirement for the V-amp right here, that's the one you're going to need to calculate the R2, R4, R6, and also R8, R9, and R10. Okay. So how you can do the calculation is, first of all, you know V in right here. Okay, so that's your input. It's 1 volt VPP, right? Then the output is 100 million VRMS. And so that's a bad writing, but you know what I mean. First of all, you need to transfer the unit. Okay, that's a VRMS, that's a VPP. So you need to transfer either VPP to VRMS or VRMS to VPP. Okay, so after you have the input and the output at the same unit, you need to know the gain of the circuit. Okay, so basically the music will pass through the circuit in this three-way in different frequency, which means the gain of each pass will be same. Okay, so which means you can use the same value for R4, R6, and R2. Then at the end, and also R8, R9, and R10, they can have the same value. Okay, since the gain will be same. Then how to calculate the value for R2 and R8 or R4 and R9? So you need to use the equation right here. Okay, so this part is not hard to understand. Let's say the first amplifier, I'm giving an example of the bandpass filter. The first amplifier, let's call this amplifier have a gain of A. So let's say that's gain A. And then the second amplifier, the gain will be gain B. So then you can have the equation. V-amp, which is the output, is equal to V-in times gain A times gain B. Okay. Then you can do the calculation. The gain will be something like this. And then you can, according to this gain, you can calculate the value for the R4 and R9. Okay. So let's give a example here. So for example, if you do the calculation, the gain A times gain B is equal to, let's say, just equal to 1. Okay. Then theoretically, you can make gain A 1, gain B 10. Yeah, theoretically, this is still going to work. But try to make those two values close together. Okay, so you can just make gain 1 and gain 1 Okay, in that case, the signal not decrease too much. Okay, so for example, if your gain is 0.1 here, that will make your like music signal or dessert signal amplitude probably too low. That in that case, probably the noise will just cover uh, the music signal. Okay, so don't make the gain A or gain B one too low and one too high. Okay. Okay, so that's how you can calculate the value you need for R4 and R9. Okay, so after that, you should have all the value you need uh, for the circuit. Okay, before I go to the screenshot you need to take, let's talk about the bandpass filter real quick. So that's the one student get confused before. So as you see here, the bandpass filter we have in the topology is just a combination of a low pass filter and a high pass filter and with the buffer in between. Okay. So if you remember the low pass filter, the magnitude response looks like something like this. Okay. So there's a decreasing curve. And the high pass filter, the curve, the magnitude response curve is something looks like this. This is a increasing curve. So if you combine these two together, you will have a bandpass filter, something like this. Okay, so remember the increasing curve, okay, or the first cutoff frequency is depends on the high pass filter right here. Okay, so the those two value, okay, the high pass filter in the bandpass filter will determine the first cutoff frequency, which should be 320. Okay, and then the second cutoff frequency or the decreasing curve right here, that depends on the low pass filter right here. Okay, the cutoff frequency should be 38.2K. Okay, so that's how you should calculate the value for those two filters. Okay, so the value is different from the one you calculate in the previous filter and the last filter. Okay, so make sure you understand how you calculate the bandpass filter value. Okay, and then last thing before I talk about the screenshot is the loading issue. Okay, so if you're, let me erase everything here. Okay, right. So if you're R1 and R2 or R5 and R4 or even R7 and R6, if the value of those two pair they are too close together. So for example, if you have R1 1K, R2 2K, okay, so that will cause some loading issue as we learned before. So what you need to do is, one way you can do is you can put a buffer in between. So that's probably will require extra work. But another easier way to solve this problem is make R2 much greater than R1. So that will solve the loading issue. Okay, same for the other two. Okay. So that's the circuit topology part and how to do the calculation for each component. Is there any questions so far before I talk about the screenshot you need to take? Any questions? Okay, if not, let's continue. Okay, so after you have the circuit schematic and after you calculate the value for each component, you can start to build the circuit, right? So that's what I mentioned in the first PPT here. Start with subsystem, okay? Which means what you need to do is just start with the filter. Okay, let's say you build a low pass filter, okay, on your breadboard, and then you just test the low pass filter, okay. So don't test anything else. Don't connect anything else either. Just test the low pass filter, and what you will have is you should have a magnitude response plot. Okay, so low pass filter looks like this, and the cutoff frequency, which is the negative 3 dB point, should be very close to 320 hertz. Okay, so that's the first screenshot you're going to have, and then you can build this part individually. Okay, the inverting amplifier, just build this part. Okay, you can even disconnect this and just build this part. And how you can verify this part is work is you can put a small amplitude signal, like let's say you put a 0.1 volt here, and measure the output right here. Okay, to say is the output expected or not. Okay, so after you verify these two individual work properly, okay, then you can connect them together, make sure they work together. Okay, and same for the other part. Okay, so make sure you do the filter part, and then then the amplifier part, filter part, then the amplifier part. Okay, build individual circuit first, and test individual first, individual circuit first. Don't do the whole thing together. Okay, so after you make each part work properly, you can connect your summing amplifier. Okay, and also make sure you have the screenshot for each subsystem. And actually, if you check the lab manual or lab requirement, it's already tell you what's the screenshot you're going to take. But I have a quick summary here. So you need a magnitude response for each filter, and make sure you mark the cutoff frequency. You want to plot proof your summing amplifier is working properly, and also a plot make sure to show you can do the volume control. Okay, so you can have one screenshot with the volume at maximum, one screenshot with volume at minimum. Okay, and for the way amp, okay, so that's the one probably require most work. If you remember the requirement here, there are three requirements right here. First one is when the knobs at minimum, so you should have one screenshot for this. Okay, so you can have a, okay, so what we will have is you still have the magnitude response. Okay, you can sweep from, okay, I have a screenshot. Okay, still you have magnitude response. Let's say sweep the frequency from 10 hertz to 15k hertz. Okay, then you measure the VRMS, which is the output. Okay, when everything is at minimum, this value should be very close to 0. And when everything is at maximum, this value should be close to 100 million VRMS. Okay. There's a way on the AD2 or the waveform software, you can change the unit to be VRMS. So you can, it's just easier to do to check it. Okay, so that's minimum and the maximum requirement and the screenshot you need to take. And the last requirement here is the ripple. Okay, ripple should be close to 15 or within 15 million VRMS. So what that means is after you plot the Vamp at maximum, ideally it will be a straight line. It's exactly at 100 million VRMS, but there could be some ripple. Okay, so let's say there is a maximum point, there's a minimum point. So what you're going to do is you measure the amplitude at those 2 points, okay, or those two frequency. Then make sure the amplitude between those two frequency, I mean the difference will be smaller than this value. Okay. All right, so that's the screenshot you need to take. Okay. Let's back to the menu here. So you're going to answer all the questions here in the in the report. Okay, so somehow you need to make sure all the answer is provided in the report. Okay, you can put this in the either you can put in this procedure part or you can put in the result part. Okay, so let's go to step 3 here. Compute the voltage supply necessary for the amplifier. Okay, so remember this amplifier is referenced to the LM386. So that's a audio power amplifier. So you can check the data sheet to answer all the questions here. Okay, so that's the one I need to mention. And then it's just the screenshot you need to take. Okay. Let's see anything else. Okay, I think that's most of the thing I want to cover right now. Is there any questions? Okay, there are a couple things besides. First of all, is the actual credits 5 is due as Friday end of the day. Okay, so I just upload the schedule for the actual credits module 5. So that's the last actual credit you're going to do. Okay, so make sure submit it on time if you want to do it. And again, the report is due at next Tuesday. Okay. Although the circuit, okay, if you check the circuit right here, it's not too complex. Okay, each especially each individual circuit, you should familiar with all of them, but still make sure you start early. Okay, because even each individual circuit work properly after you connect them, there is a chance it's not going to work. Okay, so you need some time to debug your circuit. Okay. All right. I think that's all for today. And again, I will be here same time on Thursday for office hour. Besides that, I think that's the last class for this semester, and you can start to do the final project. You need to build all 3 bands and the semi amplifier together to test it. Okay, so what I mean, you start with the individual circuit or the subsystem is you want you want to test the subsystem first. Okay, then you leave them on the breadboard, and then you connect them together. Okay, you should have enough component. Okay, I think for each. But even you want to, like, if you cannot find like enough, let's say 100K, you can use some combination. Okay, so you can make like 2 resistor in series close to 100K. That should work also. And also for the amplifier, if you remember correctly, there are 2 chips you have. I cannot remember the exact number, but probably 341 or something. There is a 10 pin or yeah, probably 10 pin or 8 pin amplifier that amplifier has have 4 op-amp inside, okay, which means each chip has 4 op-amp. Okay, so you should have enough chips. Okay, I will also open the breakout room right now. If you want individual help.
Hello. I have a question about experiment 13.
Okay. Do you want to join the breakout room, or you want us
Yes.
right here? Okay. Yeah, you can join one breakout room.